Alright, welcome to our first video covering hyperbolas. And in this video, we're just going to introduce a lot of the concepts and the pieces and parts for hyperbolas and get into some examples in future videos. So the definition of a hyperbola is pretty much the same as the definition of an ellipse. The only difference is that we're going to replace the word sum in the definition of ellipse with the word difference for the definition of a hyperbola. So a hyperbola is a set of points in the plane such that the difference of their distances from two fixed points, again called foci, is constant. So with ellipse, the change was this word here. We had the word sum in the difference for ellipse where we added those distances. And in hyperbolas, we're taking their difference, so we're going to be subtracting them. So just like an ellipse, the midpoint joining the foci is the center, and there's a lot of similarities between equations and such for hyperbolas and ellipses. So whereas ellipses could appear taller or wider, hyperbolas are going to open up and down, or they're going to open left and right. So the hyperbola version of a tall ellipse would be opening up and down. The hyperbola version of a wide ellipse would be opening left and right. So one of the biggest differences between ellipses and hyperbolas is when we looked at ellipses, the larger denominator told you whether it was going to be tall or wide. So if your larger denominator for an ellipse was below x, it was going to be a wide ellipse. If your larger denominator for an ellipse was under the y, it was going to be tall. With hyperbolas, we're going to concern ourselves with which denominator has a positive sign in front of it. So if our sign in front of x, the x term is positive, then it's going to open left, right. And if the sign in front of the y is positive, it's going to open up and down. And it doesn't matter what the values of a and b are, even if the larger number is after the negative sign, it's still not going to come into play with hyperbolas. It's the one that's positive determines it. So here we have a hyperbola that is opening left and right. So the value in front of the x, the sign in front of the x term is the positive. So we have our center. Here I just have it centered at the origin. And we count a units left and right of the center if it's opening left and right, just like we did with the vertices for an ellipse. We count b units above and below, just like we did with the co-vertices of an ellipse. But notice this time the focal points, the foci, are further away from the vertices, from the center than the vertices are. So with a hyperbola, your focal points are always going to be inside your hyperbolas, much like your focal points for a parabola are inside parabolas. You can almost think of these as parabolas that are opening up and down or opening left and right. So we have the focal points are c units away from the center. So when a hyperbola is opening left and right, the equation is x minus h in parentheses squared over a squared minus y minus k in parentheses squared over b squared equals 1. And even if b squared is bigger than a squared, because a has the positive in front of it, that means the hyperbola is going to open left and right. So it doesn't matter how large these denominators are. What matters is the sign, SIGN sign, that's in front of them. So the biggest difference between equations of ellipses and hyperbolas is the fact that as far as left and right and up and down, it's what's positive. Also notice that we switched it from a plus for ellipses to minus for hyperbolas. Your vertices are still going to be a units away from the center, so h and k is your center, and then if it's opening left and right, you're going to add and subtract that value of a to your x-coordinate, or your h. And your foci, again, it's going to be left and right, c units left and right of the center, so adding and subtracting that focal length from c is to your x-coordinate for your foci. Your x-axis, if it's opening left and right, is called your transverse axis. It is not the major axis. That's for ellipses. So you can think of the x-axis, the transverse axis, as the hyperbola's major axis. The y-axis is called the conjugate axis. So that ties in with the minor axis for ellipses. And with hyperbolas, your value of c is going to be the square root of a squared plus b squared. So with ellipses, it was a squared minus b squared. With hyperbolas, it's a squared plus b squared. So we switched the plus and the minus for the equations for ellipses and hyperbolas, and we switched the plus and the minus for the value of c for ellipses and hyperbolas. You also have these asymptote lines, which will guide how wide open your hyperbolas are. And if h and k is your center, then your slope of your line is going to be a rise of b and a run of a. So b over a is our slope. A positive slope's going left and right. A negative or positive slope is going up to the right, and a negative slope is opening down to the right. So plus or minus. And then x minus your x coordinate of your center plus your y coordinate of your center. So this is a variation on slope-intercept form, where we have our slope here. We actually have two different lines. We have our slopes here, and our y-intercept we would find by distributing this and combining it with the value of k. So it's easier in actual examples to find the equations. For ones that are opening up and down, again, notice that this time we have our vertices are above and below the center. The focal points are above or below the center, still c units away. This time, because the the graph is opening up and down, the sign in front of the y term is positive and the sign in front of the x term is negative. So these equations are going to have the form y minus k in parentheses squared over a squared minus in parentheses x minus h squared over b squared equals 1. This time we're going to add and subtract the value of a to the y coordinate for our center to get our vertices. And same thing with the value of c. If it's going up and down, above and below the center, we're going to add and subtract that value of c from the y coordinate. Your x-axis is the conjugate axis. Your y-axis is the transverse axis. So again, the transverse axis is the hyperbola's version of the major axis. The conjugate axis is the hyperbola's version of the minor axis from ellipses. And again, c squared is still going to equal a squared plus b squared. And this time our asymptotes, we have a rise of a units and a run of b units for these dotted diagonal or dashed diagonal lines. So the slope is a over b, and we got one going up, one going down, so that's the plus or minus, and again, x minus h in parentheses plus k. So that about does it for this video. In the next video, we'll look at some examples. So I'll see you then.